Professor Borong Lin is a Deputy Dean of the School of Architecture at Tsinghua University. And he also serves as the Dean of Key Laboratory of Eco-Planning and Green Building, commissioned by the Ministry of Education. And he is the Fellow of FIBPSA. Professor Lin was awarded the National Changjiang Scholar, National 10,000 Talents in China as the Scientific and Technological Innovation Leaders and the 2020 Explorer Prize. And Professor Lin is also the editorial member of Building Environment, Sustainable City and Society, Building Simulation, and other peer-reviewed journals. Okay, so I will hand over to Professor Lin for his talk. Professor Lin, please.
Okay, yeah, thank you, Lei. Hello, everybody. Good morning and good afternoon. Thank you for your attention. So I'm sorry, at the beginning, there is a sudden meeting for the COVID-19 prevention and control. So sorry, I couldn't open speech at the beginning. And now I want to give you a talk about the intelligent building design in operation. Okay, so a moment. So you see the screen?
Yeah, we can see your screen.
Okay. Okay, yeah, thank you. So the background of this talk is firstly is the 30 or 60 carbon neutrality target proposed by the Chinese government. In fact, there are many challenges and also opportunities. Because this means ground challenges for China. Firstly, is the big emission task. That means twice than that of United States, and 3 times than that of European Union, 208 countries. The second challenge means a shorter neutralization time, because it is about 7 first years for EU and also 43 years for United States, but only 30 years for China. And also the most challenging for China is because the low carbon development has not yet been decoupled from the economy development. But for the EU, you can see this and this for United States. The economy still increased, but the carbon emission keep a stable level. So these 3 challenges will be a big problem or maybe opportunities for us to carry out the carbon tasks in different sectors, including in building sectors. The second challenge is the height and the pressure issue. Due to the COVID-19 pandemic era, that has become a top trigger for the global building industry. And IEQ plays an important role in the human health. So even now, the Omicron still an important issue for us. So with these 2 targets, if we consider the building energy use as well as the indoor environment quality, it's a very complicated problem. With the IEA Annex 15.3, there are 6 factors for them, including the climate, the envelope, the equipment, the maintenance mode, the occupant behavior in the indoor environment parameters. But in fact, it will be more complicated. So maybe we need a systemic approach. We need to manage the complexity and to consider the unintended consequences. So we need a scientific thought. Every system must have a structure, and the system structure determines the system function. We need to use this idea to solve the building performance issues. That means we need more multiple disciplines to integrate the building science, the urban planning, energy, material information. And also we need to consider these issues in different scales, from the outdoor environment to the indoor environment, from city to the community and the building level. And also we need to integrate simulation, optimization, as well as evaluation together to improve the performance from the beginning into the operation phase. So what we can get from the new technologies, firstly is AI, advanced wide search engines and recommendation systems, understanding the human speech, the self-driving cars, and also the automatic decision making in the highest level in strategic systems. So maybe we can use these advantage technologies to improve the building performance from the beginning, from design to operation. And secondly is the big data technology. We can analyze the world based on the massive data. That means that maybe we can understand the behavior behind the data and to understand how to optimize the performance in the operation phase. And also, the third one will be the sensor technology. The world is sensing at every moment. So I passed 5 years, there are more and more sensors to collect environment data as well as the energy consumption data. So that means we can use this sensor and the data to optimize the performance. So with my team, there are some research findings from the government. First is the green building design optimization with methodology, algorithm, and platform supported by the Chinese Ministry of Science and Technology. And the second is we cooperated with UCL, is a Tsinghua UCL joint project supported by the NSFC and the FIBPSA. The topic is the total performance of low carbon buildings in China in the UK. And the third one is the research and application of the post-occupancy evaluation of green buildings, actual operation performance, also supported by the MOST. So today, what I want to show you is from the building design to the building operation, we want to introduce the intelligent solution to optimize the performance with simulation, with AI, with data mining, something like this. Firstly, I want to give a review of the research trends of building simulation for the early design slide show, such as the reverse optimization. Okay, we can take the performance indicators as the objective function to integrate the optimization algorithm in the simulation engines to search for the optimal solution, including the optimal form in the performance of the envelope as well as the building mechanic systems. And also, researchers has carried out research to optimize the software performance, such as Savara and ASVB, such as this. That means the simulation we are integrated from the beginning of for the building design, for the early stage. So if we can give a summary about this, we can see, for your design, more and more architects began their design in SketchUp and in Rhino. So there are many plugin performance analysis integrated in the mode conversion modes will be changed in the near future, and the requirement for the hardware will be higher and higher. However, we still think that there are some challenges, such as how to trade off the fast uncertainty and from the building beginning, and how to build a uniform design platform, something like this. So our research is, we think the building model space recognition is a key problem. So consider the current research. There are 4 types for organism. Firstly is the graph and the feature-based building space recognition organism. Secondly is the geometric calculation organism. The third one is the organism based on the domain-specific knowledge. And the last one is very transitional from 2D to 3D. We evaluated their performance from 2 aspects. First is accuracy, the second is the speed. And with this understanding, we carry out our solution. That means to meet the big need for an algorithm that is good at both geometry recognition accuracy, as well as the recognition efficiency. So with our understanding about the building performance design, building is somewhat like a human or a product. The performance-oriented design method could give the green genes for the building from the baby period. That means from the early stage, such as the DNA design. So what we want to control, to optimize is the DNA of the building's performance. So we carry out research to develop a software named with MOSAS. It's a performance optimization tool for the early design stage. There are 3 important features for MOSAS. Firstly is the automatic graphic recognition and conversion algorithm. Secondly is the fast simulation for energy consumption and daylighting, and recently including the ventilation. And also there is reverse or forward multi-objectives optimization approach. I just want to show you some main features. Firstly is a real-time performance analysis feedback. It can automatically recognize the 3D model and transform it into a performance analysis mode. And also it can finish the automatic simulation. And finally, there is a real-time feedback of energy consumption, lighting, and ventilation, and so on. The second feature is we realize a reverse optimization method, at the low energy consumption. That means use the energy consumption index such as less than 50 kilowatt hour per square meter per year, and also give some thermal comfort indexes as well as daylighting indexes. We can use this target to carry out parametric design. We define a function and use this function to generate a lot of possible forms integration with the envelope performance as well as the mechanical systems performance. So finally, we can generate a lot of possible schemes to meet these targets, and then architects can carry out this simulation with this basis. So here, what we introduced is very interesting algorithm is the multi-island genetic algorithm to help us to optimize the better schemes, just like the DNA, just like the genetic coding methods. Here we introduced the 34 parameters in spatial fitness penalty control. Just like the DNA, we can determine the user-specific parameters genetically encode in the generated architectural forms. This is some examples for you. A very important organism is the automatic recognition and conversion of 3D architecture models. We develop an organism based on the filtering and fuzzy matching. It can very easily to recognize the very complicated faces with a very short-hand consuming. So based on the traditional space aesthetic creation, we realized the optimization integration of the space design and the energy saving. And this is an example, a very complicated geometry. We can quickly recognize the component with less than 1 second. And also, we carry out some comparison with the other software, such as Safari, and the other software, such as Rhino, in the web platform. We think our algorithm has some advantages compared with them. The second algorithm is a faster predicting mode for the building heating, cooling, lighting load. And compared with actually 114 requirement. With these cases, we think our accuracy will be good. However, the time saving more than 50%. The three algorithm is the Pascal algorithm. We find an optimal shape quickly at the early stage. We develop independently Pascal algorithm to achieve the high performance certification rate in high convergence efficiency. Such like this, we can ensure the diversity of the optimization results with a very short period. What I show you is some cases. Just with this cascade shape, if we want to keep the energy saving with the lowest level, and also we want to control the initial cost as well as the operation cost. So we can use Pascal help us to realize the diversity of the schemes, and it can very quickly realize the optimization to meet our 10 seconds, because the speed is more than the old one is 6 times. Also, I want to show you some cases with this intelligent design approach. We can carry out an efficient method to evaluate the large-scale urban residential skyline environment. So there are some problems, challenges, and opportunity. For us, what we did is to collect the big data of the building geometries, residential boundaries, and the POIs in Beijing main area. And also we carry out some approach to automatically retrieve all the building geometry by the cloud technology. And also we get the latitude and the longitude coordinates of every residence by the Baidu Map API. And with this, we use the high spatial sampling to generate more than 30 million grid for the whole Beijing city daylighting simulation. What we used is a parallel as a VBA analyst approach. We used 16 computing nodes in 4 early cloud servers to finish this. So you can see this is the visualization of the skyline analysis results for certain large-scale residential area in Beijing. And also recently, we carried out some research on faster prediction to the outdoor wind environment based on the super resolution technology. Just use these pictures as example. With a very low resolution pictures to the real SR GAN algorithm, we can generate the very high, the super resolution pictures. So we introduced this technology for the outdoor environment simulation. Input is a very low resolution pictures, but finally we can get the higher resolution pictures. In the picture similarity of the imaging more than 90% compared with the real imaging, but the time saving will be 70 or 80%. Similar research also carried out to the FIBPSA generation by the AI. With the lowest building energy use value as the target function, we can control the FIBPSA design to control the geometric parametric, something like this. And also, we introduced the daylighting ventilation performance faster simulation approach with the CNN in GAN approach. So with this approach, the time consuming less than 1 second compared with traditional method is more than 10 or 20 seconds. And also the structure similarity index measure are more than 90%. The second part of what I want to show you is the operation with the big data. So with the traditional problems, our solution is sensing, understanding, and control, and feedback. The sensing means we develop some special sensors to collect the data efficiently. And secondly, we understanding the environment performance with a two-dimension approach. And finally, we use the data mining approach to optimize the control algorithm. Firstly, is the sensing, the sensor first for data. We develop an iBeam, an intelligent monitor. It can integrate the temperature, relative humidity, CO2, PM2.5, and emulsions, and the other parameters into a very small equipment. And it can help us to transmit data to the cloud through the Wi-Fi or 3G. These sensors finish the thermal interference simulation. And also, we finish the hardware optimization, finish the calibration under the national standard, and also get the certification by the third party. And with the web plus mobile platform support, we can carry out the data query, download, evaluation, feedback, and realize the right here, right now to collect the subjective votes in the objective parameters in the same time. So we use the V chart and the other social media tools to help us to collect this data. And now, this sensor were installed in more than 200 buildings in 31 cities in China and international. The long-term data collection, we realized the data sets more than 1.5 trillion. Especially this data, especially this sensor, were installed in the hospitals due to the COVID-19 security study in 2020. Installed in 8 hospitals in Wuhan and Beijing for the early warning of the COVID-19 risk. And also, sensors will be used for the subway stations to judge the flash air rate is enough or not for the tank in the stations. Also, we can, with this data, carry out a national level comparison to understand the IEQ performance and the mechanism. We realized the overall IEQ performance of green office buildings in China based on the big database. We can carry out the summer performance for different climate zones, the cold zone, the hot summer, cold winter, and the hot summer, winter areas. And we can compare the IEQ issues in the different seasons, summer, winter, in the transit seasons. And also, we can build understanding of the IEQ in a building level. We use the spatial tools to build a 2D environment distribution, changed hour by hour, such as this. This is for CO2, changed hour by hour. This is for PM 2.5. And with this approach, we can easily find the questions, the problems for the CO2 control in the PM 2.5 control inside the buildings. And also, what I want to show you is in a airport terminal building. It's very easy for us to find that there is a spatial difference for the air temperature. More than 9 cases in a day. And also for the PM 2.5, there is more than 70 mg per cubic meters, as well as the CO2 difference is more than 400 ppm. And also, due to the COVID-19 pandemics, we installed these sensors and use this approach to analyze the possible security in these areas. So we can very easily to find the problems for the PM 2.5 control, as well as the CO2 and the temperature and the humidity. So with this comparison, we can find if the indoor space has enough fresh air support or not. And also, we can carry out daily pattern recognition with the massive 10 series data. With these massive daily curves, we use the feature selection based on the professional knowledge and class this data to use this class curves for the future control. Something like this. We use the 5 daily curves to realize the typical pattern for different and recognize their performance and find the zone if have the poor thermal performance or not, and then give the control principles for the HVAC systems and realize the performance improvement. And also, we can carry out some prediction based on the historic data. Such as this, we use the random forest data mining algorithm to finish site prediction result for one typical day. And also, we compare the performance for different algorithms, such as ANN and the long and short 10 LSTM. Yeah. With this comparison, yeah, we can give some guidance for the algorithm selection for real project. And also, we integrated the occupant positioning plus the terminal and Wi-Fi technology. With this technology, we can realize the 1 meter accuracy to position the occupant. And also we can compare the occupant positions as well as the environment performance, the environment parameters changes all by all. And also this technology will help us to optimize the system control in the real cases. And also we develop approach that is with the real-time location plus the real-time IEQ plus the real-time vote. We realize the smart control to use the cloud-side IEQ and to obtain the control strategy. So we can use the sensor plus the mobile phone to transmit it to the cloud and use the cloud simulation to optimize the real performance and get the subjective vote from the occupant to realize the smart control. This approach has been applied in Shanghai Hongqiao Airport Terminal 1. We realized the energy saving for the IEQ, especially for the flash air supply in the daylighting control in the HVAC system energy saving. Generally, it's about 60% energy saving. And also the IEQ certification rate was improved more than 85%. There's some images for the sensors installed in the airport. So due to the time limited, what I want to show you is this. I want to give a summary. I think we need a high city in the future. And also due to the 30-60 carbon neutrality targets, there are more and more energy saving in carbon reduction pressures from the government. So due to these two restrictions, we need to use the intelligent design as well as smart operation approach to realize the building performance improvement in the future. So from design to the operation, what I want to show you is our approach in the past 5 years. I hope in the future can we use this approach more and more in the real project, and hope more collaborations in communications with you in the future. So that's my talk. Yeah, thank you.
And thank you, Professor Lin, for your impressive talk. So let me start our QA session. Is there any question from audience for Professor Lin's talk? Professor, may I ask a question about your work? Yes. So okay, for the first part, yes, for the first part of your presentation, you mentioned optimal design software. So I'm wondering, so this software is developed from scratch. This is a completely new software, or is developed on the top of existing software? It's like
okay,
yeah.
Thank you, Professor Tang. It's a new software. It was launched at the middle of 2009. This software, in fact, has been integrated with another commercial software. It's a PKPM in the China Academy of Building Research. And,
okay.
Until last year, there are more than 100 users and more than 700 projects use this software. This software will be free for the education users. So in the future, we hope more and more faculties, students from the university could give us some feedback with this software. In fact, in some other universities, such as in Shenzhen, in Australia, many professors also help us to use this software to carry out the research and teaching tasks for the undergraduate students.
Okay, we will look more for the software. It's very interesting. And is there any other question from the audience? So you can put your question in the chat, or you just unmute yourself.